Hello everybody, welcome to this video. My name is Caleb, and in this video I want to talk about adding and subtracting binary numbers. So understanding how computers add and subtract binary numbers is very important for when you're working with technology and computing and so forth. So mainly, there's a few different ways that you can do it, and I'm going to be explaining a couple of them. So basically we have a binary number which consists of bits of 1 or 0. If you don't know much about binary, you can check out my introduction to binary video. But we have 1 or 0, and then each place marker, so as we add more place markers, it multiplies by 2. So we start 1, 2, 4, 8, 16, and so forth. So if we have a binary number such as 1011, well, we know this is 1, this is 2, this is the 4th place, and this is the 8th place. So we can use this to figure out what number this is. Well, we have a 1 in the 1's place. That means we count it. So we have a 1, we have 1's in the 2's place, a 2. We don't have a 1 in the 4's place, so we don't count that. And we have a 1's in the 8's place, 8. So our final answer is 8 plus 2 plus 1, or 11. So that's how you quickly figure out a binary number. But sometimes it's important to understand how binary numbers are added. To start learning about this, we're first going to look at how to add 1 to a binary number. So we start with a 0, correct? Now if we want to add 1 to this, well, we're in the 1's place, and we're using a 0, which means that's nothing. So to have 1, all we have to do is replace this with a 1. Well, since we're in the 1's place, the highest, or the first place, the highest value we can have is 1. So we can't add any more to this number. So what do? We have to go to the next place marker. So 1 plus 1 equals 2. And this is the second place marker. So now we have 2. And then we fill in the other spots with 0. So what do we do now? Well, 2 plus 1, if I want to add 1 to this, it would be 2 plus 1 equals 3. Basically 2 plus 1 equals 3. So this is equal to 3. So what can we do now? Well, what about 4? Well, that means we'd have to go to the 4's place, and we would get this. 4 plus 0 plus 0. Now 5 would be this. 4 plus 1. 6, well, that's 4 plus 2, so 4 plus 2 plus 0, 6. 7, 4 plus 2 plus 1, and so forth. So once we reach all 1's in every single spot, the way to go to the next number is we add an extra place marker, and we replace all the 1's with 0's. So this is 1, this is 2, this is 4, and well, all of these add up together, and then if you add 1, it goes to this. So 4 plus 2 plus 1, that's 7. So if we need to store 7, we can fit it within these 3 spots, but if we need to store 8, we have to place them all within the 8th spot and replace them with 0's. So now that we understand how to add 1, we can start figuring out how to add numbers. Well, there's one way we can do it. If you're not used to binary, we can convert them to decimal and then add them in decimal. So let's say we have a 4-bit word length, and we have 1111 and 1101. First thing we can do is figure out what these are in decimal. So just go back to the method I just taught you. 1 plus 2 plus 4 plus 8. One plus 2 plus 4 plus 8 for each spot within the binary word. So this comes out, 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So the final value is 15. And then if we want to add this, well, we can figure out what this one is. Well, we got 1, 4, and 8, so we get 13. And then what we do is use decimal mathematics to figure out what the final answer should be. So 15 plus 13. Well, 5 plus 3, that's 8. 1 plus 1 is 1. I mean, not 1, sorry. 2. 1 plus 1 is 2, in case you guys didn't know that. So the answer was 28. So now we just have to figure out how to represent 28 in binary. Well, we can find the place markers thing I told you. So this is 1. Yeah, let me just write this like this. 1. This is 2. This is 4. This is 8. And this is 16. Well, then you figure out how many you're going to need. Well, if we just use this, we can only store it up to 1. If we use this, we could store up to 3. If we use this, we could store up to 7. If we stored up to this, then we could store up to 15. If we stored this, we could store up to 31, I think. So now we can store it within a 5-bit word length. So the answer would be 16. Then we could add 8, for example, which would give us 24. And then we can add 4, which would give us 28. So this is how we represent 28 in binary. 16 plus 8 plus 4. So we just write that up here. We had 0, 0, 1, 1, 1. And then if you want them all to, I guess you could make them all the same bit word length, but that's not required. So here is our final answer. So we basically, all we did was convert the binary into decimal, base 10, which you may be used to. Occasionally, you're going to want to work with binary without having to convert it to decimal. So we need to learn how to add binary without converting it to decimal, obviously. So there's a few things that could happen. Occasionally, you will have to add 0 and 0. Well, this is obviously equal to 0. You may have to add 0 and 1. Well, this is obviously equal to 1. You may also have to add 1 and 1. Well, this is equal to the binary 2. Not 10, we're in binary, so this is 2. This is the 1's place, this is the 2's place. So this right here is equal to 2. And then, how do we represent this when we're using math in binary? We have to carry the 1 to the next placeholder. So let's try this in an example. Let's say we have and we want to add these, correct? Yeah, let's look at that. Well, 1 plus 1, that's equal to 2, but we can't drag both of those down in one placeholder. What that means we need to do is place the 1 up here and the 0 down here. This is because this row right here, or column right here, is the 2's place. So in order to represent 2, we add a 1 to the 2's place and put a 0 in the 1's place. Now here, we have 2 1's, and if you look at the place marker, this would be 2 plus 2. We can just think of it as the same thing. Carry the 1 over and drop a 0. So basically 2 plus 2 equals 4. And we are on the second, so basically, yeah, you get the point. 1 plus 1 again, we would carry the 1 and drop the 0. So this is the final answer, because we had to carry the 1 into the next location. Occasionally, when you're carrying the 1 over, you're going to get 1 plus 1 plus 1. Well, this is another thing you're going to run into. And to do this, you have to carry a 1 and drop a 1. So why is this? Let's say we have we're going to add these together. So, just so we know we get it correct, this is 3 and this is 3. So the answer should be 6. But we're just going to work through it. So 1 plus 1, that means we carry a 1 and drop the 0. Now we have 3 ones. So what should we do? Well, like I said, this would be the equivalent of 2 plus 2 plus 2, or 6. So now we have to carry one of the ones into the next place marker and drop a 1. So this is going to fall, and we get 1, 1, 0. This is because this is the 1's place, 2's place, and the 4's place. 4 plus 2 is equal to 6. So to give you all the possibilities here, we get 0 plus 0, 0 plus 1, 1. I guess you could have 1 plus 0, that's pretty much the same thing. So you can get 1 plus 1, and then you can get 3 cases of 1. And what you do for each one of these, here you get 0, here you get 1. This one, you carry a 1 and you get 0. This one, you carry a 1 and you get 1. So those are all the possibilities with binary. So if we try a binary number, let's try, and then we have 1. So now this is a big number. Here we have 2 1s, so we carry a 1, drop a 0. Here we have 3 1s, so we carry a 1, drop a 1. Here we have 2 1s, drop a 0, carry a 1. Here we have 3 1s, so we carry a 1, drop a 1. Here we have 2 1s, so we carry a 1, drop a 0. Here we have 3 1s, so we carry 1, drop a 1. 3 1s again, so we carry 1, drop a 1, and then we just drop the 1 because we don't have to add anything there. So this is the final answer of this binary number. And then what you can do is you can figure out what these are in decimal and represent that by saying, oh, this is equal to whatever, which I'm not going to do that right now because we just explained how to do that, and it's a waste of time to do it over and over again. So now you understand the basics of adding in binary. Now that you know how to add in binary, we are going to learn how to subtract in binary. Woo-hoo. So this one's a little more complex. It's not too hard, so don't freak out. Be okay. Everything's gonna be all right. So for these examples, we're going to assume that the top number is larger than the bottom number. To subtract when the top number is lower than the bottom number, we'll be getting into that in a future video. So stick with this now to figure out how to subtract smaller numbers from larger numbers. So just like in math, not just in math, just like in addition, we had some basic examples such as 0 plus 0 being 0, 0 plus 1 being 1, 1 plus 1 carrying the 1 and dropping a 0, and then 3 1s, which only happens after you've already carried a 1. So if this carries into this one, well then you drop a 1 and carry the 1. Well, those are all our possibilities for addition. Well, there's also for subtraction. So we can get 0 minus 0, which, easy enough, 0. That's subtraction sign, not a negative. Okay. Then we could have 1 minus 0, which is going to give us 1. Because if you have 1 and you take 0 away, you're still going to have 1. We could also have 1 minus 1. Well, if you have 1 and then you take 1 away, oh, well now you have 0. You see? So that's pretty simple. But what if you have 0 minus 1? So, 0 minus 1, well, we actually have to borrow from the next place marker up because we can't, this will give us negative 1, which we're not going to represent that here because let's say we're in the ones, let me just give you an example here. 1 0 0 1. Well, if you look at this, 0 minus 1, that's in the 1's place. These are in the 2's place. So, basically we could borrow from the next place marker up. We take a 2 from here and bring it to the 1's place. So we can represent this. So we had by crossing out this 1, you see? And then adding 2 to the first column. Well, you can represent that as that, or you can represent it as two ones, which I like to do this. So we just basically took this 2 and turned it into 2 copies of 1. It's equal in math, so 2 is the same thing as 1 plus 1, but we're just moving it down to place value, so this is what we get. Now, we subtract 1 from these copies, so we get rid of 1. We subtracted 1 from the 2, and we're left with 1. So that's kind of confusing. Basically, what we're doing is we're breaking this 1 in half. So it was originally 2. Well, we're going to break it, this is in decimal obviously, and we're going to break it into 2 copies of 1. Or if you want to think of it in binary, it could be, we're breaking this into 2 copies of 1. And then what we're doing is we're subtracting 1 from this value here. So we get rid of one of them. And then we're done with that. So now all we have is 1 left over. And this is now 0 because we stole it to use it for this place. So now we have here 0 minus 0, and we get 0. So that was our final answer. So basically, if you want to see that again real quick, we had 1, 0, 0, 1. Well, we borrowed the 1, replaced it over here, and then we subtracted a 1 from that, and we get 1. Make sense? So here's our final answer. So what are these values? Well, this here is 2, this here is 1. In decimal, 2 minus 1 is equal to 1. So that's our final answer. That is how you subtract in binary. Another way to think of it is like this. Let's say we have 1, 0, 1 and 0, 1, 0. 3-bit word length. 1 minus 0, that's easy, 1. Well, 0 minus 1, you can think of it as, rather than 0 minus 1, you can think of it as 2 minus 1. And the final answer for that is 1. So 2, this is the first row, is 2. This row is 1. 2 minus 1 is 1. So our final answer is this. So we started with this, 0, 1, 1, 0, 1, and 0, 1, 0. What are these values? Well, this is 5 in decimal. This is 2 in decimal. 5 minus 2 is 3. How do we represent 3? We represent it like this, which is the same thing as this right here. So that is how we subtracted in decimal. So to do a quick review of subtraction in binary, we can subtract 0 from 0, we get 0. We can subtract 0 from 1, and we get 1. We could subtract 1 from 1, and we get 0. And we could also, if we have 1 minus 0, 0 minus 1, well then we have to borrow from the next placeholder up and bring them down here, and then we subtract and drop the 1. So let's try a bigger equation that will illustrate this. Let's say we have 1, 1, 2, 3, 4, 5, 6, 7, 8. What's 8-bit word? 0, 1, 0, 1, 0, 1, 0, 1. And we're going to subtract this. We want to find the final value. Well, just starting out, we have 0 minus 1. So what does this mean? That means we drop a 1 and replace this with 0. Or basically, bring this over here and then subtract, and we get 1. Either way, you can look at it either way. 0 minus 0, that's 0. 0 minus 1, once again, we have to borrow from the next placeholder up and drop a 1. 0 minus 0, that's 0. 1 minus 1, that's 0. 1 minus 0, that's 1. 1 minus 1, that is 0. 1 minus 0 is 1. So here is our final value when we subtracted this number from this number. So that's pretty much all you need to know when it comes to adding or subtracting binary numbers and getting a result that you figured out yourself. Remember, from the beginning, I said you could just convert them to decimal and then do the conversion, like the subtraction or the addition, to get the final answer, and then you can convert that back into binary. Or you can use these methods I taught you just now. If you have any questions, be sure to comment, and I'll do my best to answer them, hopefully. Hopefully, I try. And please like this video if you liked it and enjoyed it. Also, if you want to learn about subtracting a smaller number, such as 01 from 101, well, how can we do this? Well, that's something that I'm going to be going over in a future video. I think I'll title it 2's Complement. So, 2's Complement, something like that. I don't know why I do that. I always start writing something, and then I get tired of writing it, so I just kind of scribble. But yeah, that's all I have to say. So I will see you in the next video. Be sure to subscribe.